Hey, Mr. Tarrou. Okay, today we're going to take a look at solving trig functions. We're continuing that idea that we're solving equations that involve trig functions, only this time they're going to have multiple angles, and we're going to be looking for all solutions between 0 and 2 pi, like we did in my previous video. Only again, we're looking at multiple angles. So what is that what is that going to look like? Well, here's the first example. We've got 2 cosine of 2x minus 1 equals 0. And we want to solve this for all x values between 0 and 2 pi. Well, if this material hasn't been taught to you yet, and you're just trying to go through your book and you're working these out, and you're looking at this, okay, I want all my answers between 0 and 2 pi, you're going, okay, I need to find the angle measure. And I need to get, 2x by itself. Well, that means we're going to add both sides by 1. Divide both sides by 2. So undo that multiplication of 2. And now we have the cosine of 2x is equal to 1/2. Now please remember that this is a trig function. It's not just a variable. It's not cosine times 2 times x. So we can't just simply divide away this 2. It's the cosine of 2x. I like to keep my angle measures wrapped up in a set of parentheses. Not mathematically necessary, but it really highlights that it's a math function of cosine being applied to this angle measure. Now, you want that cosine function, again, to get away from the angle measure of 2x, this double angle. And you want to do the cosine function by doing the inverse. So, we have 2x equals the inverse cosine of 1/2. And don't forget, we put the sides of a triangle, in this case cosine being x over r, we put the sides of those triangles into the trig function and get out an angle measure. So again, if this is a brand new question and you've never done these before, you might be thinking, well, okay, again the 0 to 2 pi, where is cosine equal to 1/2, or what's the answer to the inverse cosine of 1/2? Well, that's 2x is equal to, okay, cosine is equal to 1/2 at pi over 3. And so pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Oh, that's right, 5 pi over 3 is the other one. And you might be thinking, okay, well that's the 2 places on one rotation of a unit circle where cosine is equal to 1/2. And you finish the question out by multiplying both sides of this equation by 1/2. Because, we're not looking for trying to solve for the angle measure of 2x, but we're trying to solve for x. So we get x is equal to 1/2 of pi over 3 is pi over 6, and 1/2 of 5 pi over 3 is 5 pi over 6. So the direction said solve for x, and I want all my answers between 0 and 2 pi, but this is 30 degrees and this is 150 degrees. I haven't even made it halfway around the circle yet, so there might be some more possible answers, and indeed there is. See, the deal is, if you want all your possible answers, what you have to focus on here is this double angle. And this 2x, or the multiple that is in front of the variable you're looking for, the x, okay, that multiple that's in the angle that you're trying to solve for, that actually, basically, you could think of this as how many times you need to go around the unit circle. I just went around the unit circle once like we normally have ever done when we deal with trig functions, but when I took that last step of dividing both sides by 2 to get x alone, we actually got some relatively small angle measures, and they're correct, but they're not all of them that are within 0 to 2 pi. Now, it says that x needs to be between 0 and 2 pi, not your final answers. So we're not looking to do the inverse cosine of 1/2 around the unit circle just once, all the answers that are around that first rotation of the unit circle, but we're going to have to go around twice to get all of the possible answers. So now you're bringing in an old concept of coterminal angles. we've already got the two places around the unit circle where cosine is equal to 1/2, but where are the other two? Well, one way to figure this out is to simply, count out again. Like our first answer was at pi over 3, so I can just make another full rotation and land back at pi over 3. So we got 1, 2, 3 pi over 3, 4, 5, 6, 7 pi over 3. So the other answer is going to be 7 pi over 3. Now, if you have a really large multiple, and maybe you don't want to just swing your arm around or put a bunch of tick marks on your paper, the only other option to find a coterminal angle, of course, is by adding by 2 pi. So if I want my fourth possible answer, and to show you another way of doing this, you have to come off to the side of your scratch paper and do, okay, well, what is 5 pi over 3? And let's add another full rotation of 2 pi. Well, you're going to need a common denominator. So I'm going to multiply the top and bottom by 3, and we get 5 pi over 3 plus 6 pi over 3. Okay, some other possible answer, therefore, now that we have a common denominator, is 11 pi over 3. So we have, again, the new idea of solving these equations with trig functions when you have a multiple angle is just remind yourself that multiple on the angle is simply telling you how many times you need to go around the unit circle so that when you're done, you have all of the possible answers that are required based on the directions. So now we have 4 possible answers from going around the unit circle twice, and 7 pi over 3 and 11 pi over 3 are bigger than 2 pi, but I haven't finished my last step, which is multiplying both sides of this equation by 1/2. And now we've got the pi over 6. We've got 1/2 times 5 pi over 3, which is 5 pi over 6. And then 7 pi over 6 and 11 pi over 6. And this isn't always going to happen, but all of these answers here are on the unit circle, and we are comfortable knowing that all of those are definitely indeed less than 2 pi. So one last time before we do our last 3 examples, with multiple angles, that tells you how many times to go around the unit circle to find all of your answers. So a couple more examples. Orange chalk's not wanting to erase very good. Okay, so we have tangent of 3x over 2 is equal to negative square root of 3. Well, this one's already set up. The only oddity is this whole 3 over 2. Well, 3 over 2 is 1.5, so we're going to want to go around the unit circle 1.5 times to get all of our possible answers that we want. So 3x over 2 is equal to the inverse tangent of negative square root of 3. Tangent is negative in quadrants 2 and 4. So what first answer do we have? What first angle do we have in our first 1.5 rotations that puts us in quadrant 2? Where, of course, tangent is negative square root of 3 over negative square root of 3. Well, if you remember your unit circle, and certainly by now you have, at 2 pi over 3, your coordinate is negative 1/2 square root of 3 over 2. And when you take that y over x, the ratio for tangent, the y value of square root of 3 over 2 over negative 1/2 does cancel out to be negative square root of 3. So our answers here are going to be 3x over 2. First answer is 2 pi over 3. And then with that first 1.5 rotations, we're again getting from the multiple of 3 halves, 3 divided by 2. We got 2 pi over 3, 3, 4, 5 pi over 3, 6, 7, 8 pi over 3. And I don't need to go around 2 full rotations, again, because my multiple is 3 halves, or 1.5. So we need to go around the unit circle 1.5 times, and these are my 3 possible answers. So our last step is to get that x value alone, which means we're going to need to multiply both sides of this. Well, it's not really an equation, it's just a list of answers, but multiply everything by 2/3. That cancels out, and we get x is equal to, well, 2/3 times 2/3 is yes, 2/3 is equal to 4/6, and 2 times 5 is 10/9, and 2 times 6 is, or 2 times 8 is 16/9, 16 pi over 9. So there we go. Our three answers between 0 and 2 pi for the tangent of 3/2x equals negative square root of 3. Okay? All right, let's go on. Okay, for our next example, let's take a look at the cosine of 2x minus pi over 4 equals square root of 2/2. All right, so this is kind of a funny looking angle, 2x minus pi over 4. I think we're going to have to need to go around that unit circle two times, and let's just see how the negative pi over 4 works out. Well, we're going to have to get our cosine function away from the angle measure, as always. So 2x minus pi over 4 equals inverse cosine of square root of 2/2. And that means we're going to have 2x minus pi over 4. And inverse cosine of square root of 2/2, where on the unit circle is cosine equal to this ratio? That would be at pi over 4, 7 pi over 4. How about pi over 4 plus 2 pi to get that next rotation in? And 7 pi over 4 plus 2 pi. So that's going to give us 2x minus pi over 4 equals pi over 4, 7 pi over 4. Find a common denominator here, just showing you some other ways to work these out. And again, just reemphasizing that, when you go one full rotation away, that's the idea of coterminal angles. Those are when the trig functions are equal. So we got 8 plus 1 is 9. And finally, we got 2 and 4 is 8, and 7 is 15. Now let's deal with this pi over 4 that's over here. Well, I got to move it over and add pi over 4 to all of these answers, so I'm adding by pi over 4. I'm also running out of space, so we're going to have 2x is equal to 1/4, and 1/4 is 2/4. 7/4 and pi over 4 is 8 pi over 4. 9 pi over 4 plus 1 pi over 4 is 10 pi over 4. And pi over 4 plus 15 pi over 4 is 16 pi over 4. Okay, so our last step is to divide everything by 2, or multiply both sides of this sort of list of answers, this kind of an equation. Multiply everything by 1/2. And what do we have? We have x is equal to 2 divided by 2 is 1, so pi over 4. 8 divided by 2 is 4, and 4 over 4 is equal to 1. Then we have 10 divided by 2 is 5, so 5 pi over 4. And 16 divided by 2 is 8, and 8 divided by 4 is 2 pi. Now, remember that negative pi over 4 thing there? because that minus pi over 4 is there, if you look and make sure that you want to make sure that all of your final answers are actually within the restriction given to you by the directions. And of course, I have 2 pi. It's in the interval, but I have a round parentheses here, which means I want to go up to 2 pi, but not actually include it. So that subtraction there is causing us to make sure that, to say, hey, don't forget to double check your answers. And I basically just went a little bit too far and got one extra answer that I didn't need or want. All right, so one last example, and we're going to call this video a day. Let me double check, make sure I have that right. Yep. Okay, one last example. And this example is going to give me lots and lots of answers. So let's just make sure I got enough room here. Okay. Here we go. Here we go, here we go, here we go again. Oh, probably should have sang that. Sine of 2x. What's my weakness, math? Plus sine of 4x is equal to 0. Okay. Well, we got to solve this. How are we going to do that? Because we also have multiple angles here, but they don't even match. Now that's a problem. This is effectively like having 2 variables in the same equation. So unless we can factor those apart or do something with their identities, this is not going to be solvable. But if I use a double angle identity for sine to reduce this down, I will have something that I can actually solve. So we have the sine of 2x and the sine of 4x. I'm going to use this identity. The sine of 2x is equal to 2 sine x cosine x. It's not so important that this is 2 and this is 1x. What's important is this angle is double what these 2 angles are. So I have a 4 here instead of a 2. Well, that just means I'm going to have 2 x's here. So the sine of 4x is equal to 2 sine of 2x cosine of 2x equals 0. And now we still have these 2 equations, or these 2, variables, but they'll factor apart, and that means we can actually work this out. These 2 terms both have a sine of 2x, so that's going to come out. Sine of 2x divided by sine of 2x is 1, plus sine of 2x divided by sine of 2x, this cancels out. We get 2 cosine of 2x equals 0. I'm going to set each one of these factors equal to 0. Solve each one, where is sine equal to 0? And again, we're talking about a double angle, so I have to go around a unit circle twice. And that's going to be at 0, pi, 2 pi, and 3 pi. Again, 0, pi, 2 pi, 3 pi. If I continue to go all the way around, I'm going to get to 4 pi. But that's going to be too big because of the restriction that I raised. That has to be between 0 and up to 2 pi. If you add an extra one in there, you're going to notice that it's too large when you go back at the end and you check your answers. So we're going to subtract both sides by 1. Divide everything by 2. Again, inverse trig function, so 2x is equal to the inverse cosine of negative 1/2. Again, with going around the unit circle twice, that's going to be 2x is equal to the inverse cosine of negative 1/2. That's 2 pi over 3. And 4 pi over 3. And 1, 2, 3, 4, 5, 6, hello, 1, 2, 3, 4, 5, 6, 7, 8 pi over 3. And finally, 9 pi over 3. No, that'd be 10 pi over 3. Okay, and Woo! All right, run out of breath here. Multiply everything by a half. Oh man! And we get 0. Pi over 2. Pi. 3 pi over 2. And from this factor, we get 1/2 of 2 pi over 3 is pi over 3. And 1/2 of 4 is 2, so 2 pi over 3. And 4 pi over 3. And 5 pi over 3. And just because I'm a little bit paranoid, double checking my answer before I tell you guys are okay. And bam, I'm Mr. True. Go do your homework.